Alright, welcome. This is the solutions for quiz 1. Alright, first question asks you to show your work. Determine the cotan of 5 pi over 3. So the first thing that I like to do for evaluation questions involving reciprocal trig functions is to rewrite them as regular trig functions. Cotan is 1 over the tan. So I'm going to write that 1 over the tan of 5 pi over 3. Okay, the next thing I'm going to do is I'm going to acknowledge that the tan of 5 pi over 3 is either going to be the plus or the minus of the tan of pi over 3. Whether it's positive or negative is going to depend on the quadrant that we're in. So this is where we need the quadrant information. So I'm going to draw a circle diagram. 0, pi over 2, pi, and 3 pi over 2. Okay, and I'm going to draw the angles. So 5 times pi over 3 is 5 times 60 degrees. So here's my first increment of 60. Second increment of 60, 120. We're still in this quadrant, the S quadrant. And we get to the third increment. Okay, we're at pi. The fourth quadrant, or the fourth increment, we're inside the T quadrant. And then the fifth one, we're inside the C quadrant. Change my pen color for a second here. Okay, so C, A, S, T. All right. So based on this, my highlighter here, so we're here, we're in the C quadrant. That's where you figure out the plus or minus. The tan function is negative inside that quadrant. So we're going to have 1 over negative tan of pi over 3. Now we have to figure out what the tan of pi over 3 is, and then you either get that from a table or use a special triangle. I'm going to use a special triangle. So pi over 6, pi over 3, 1, 2, root 3. Okay, and then the tan of pi over 3 is the side opposite that over the side that is adjacent to that. So we have root 3 opposite over 1. So just root 3. So we get minus 1 over root 3. Your answer. All right, second question. In the second question, we're given a function f of x, and we're asked to find its inverse. First step is I'm going to replace f of x with y. I'm going to say y is equal to 3 plus 2 times the ln of 5 minus x. And then I'm going to swap variables. I'm going to swap the x's and y's. Swap x and y everywhere. So when we do that, I'm going to get x is equal to 3 plus 2 times the ln of 5 minus y. And then from here on, what we're going to try to do is we're going to try to isolate for y. Once we do that, whatever we have for that will be our inverse. Okay, so I'm going to subtract 3 from both sides. Next step, I'm going to divide both sides by 2 to get the log function all by itself. Okay, the next step, I'm going to exponentiate. I'm going to raise both sides as powers on a base of e. So exponentiate on base e. I'm choosing a base of e because the cancellation law will allow me to get rid of the log if I use that base. So e to the power of x minus 3 all over 2 is equal to e to the ln of 5 minus y. E ln cancels. It's the cancellation law. Okay, so we have e to the x minus 3 all divided by 2 is equal to 5 minus y. Add y to both sides, subtract the exponential from both sides, and we get y is equal to 5 minus e to the x minus 3 all divided by 2. And we can make our conclusion. Thus, f inverse of x is equal to 5 minus e to the x minus 3 all divided by 2. That'll be our answer. All right, next question. So let's save. Okay. Next question. We're given two pieces of information. We're given that the ln of the square root of a plus b is equal to 5, and the ln of c minus a is equal to 2. It's not possible to solve for a, b, and c. There's not enough knowns. You have 3 unknowns, and you only have 2 equations. So you can't get a all by itself, b all by itself, or c all by itself, but fortunately you don't have to. We're asked to determine the value of a quantity that is a function of those quantities. In the first line, what I'm going to do is I'm going to use the fact that there's a log property. The log of m multiplied by n is the log of the first thing, log of m, plus the log of the second thing, log of n. And here we have the log of a times b multiplied by c minus a cubed. So we have the log of the first thing plus the log of the second thing. Okay, so m in this case was a plus b, and n in this case was c minus a all raised to the power of 3. Okay, the next step is I'm going to use the log of m raised to the power of n is equal to n times the log of n. I'm going to use that on the last term to bring the 3 down in front. So ln of a plus b plus 3 times the ln of c minus a. We got a little bit of work to do in order to use the information that was given. In particular, ln of a plus b is equal to 5. We have to manipulate this in order to make use of it here. So this square root we should convert to a power. Square root means power 1/2. Next step, we use that log property to bring the power down. The one that we just previously used, the last one in purple there. So we have 1/2 times the ln of a plus b is equal to 5. Then multiply both sides by 2. So the ln of a plus b is equal to 10. So I'm going to use that information here. 10 plus 3 times, and then we have the other information. Ln of c minus a is equal to 2. So we'll use that information there. And simplify. So 10 plus 6, 16. So it's a bit of a puzzle question. All right. Question 4. Show whether each of these is even or odd. To show something's even or odd, replace all the x's by negative x's and see what happens. Okay, so all those x's got replaced by negative x's. Now, might as well write straight down. I'm going to make some comments here. One comment is that cosine of x is even. So cos of negative x is equal to cos of positive x. So we have cosine of positive x over e to the negative x plus e to the positive x. Another comment is that e to the negative x plus e to the positive x is the same thing as e to the x plus e to the negative x. Just order of addition does not matter. Make makes no difference how you add things. So this is just f of x. And whenever f of negative x is equal to f of x, that means the function is even. That's our answer, even. So 1 mark for the correct answer, 1 mark for showing your work. Okay. Same idea for this. We'll see what happens if we replace all the x's by negative x's. Sine of the tan of negative x cubed plus the cos of negative x over negative x. Okay, negative x cubed is negative x times negative x times negative x. It's just negative x to the power 3. We already stated above that cos of negative x is the same as cosine of x. Nothing much happens down below. Okay, the next line, cos of x is even. The next line, tan of x is odd. So tan of negative something is equal to the tan, or the negative tan of the positive. We bring the minus sign out of an odd function. So we have the sine of the negative tan of x to the power of 3. A negative down on the bottom can be written on top. Okay, and then the next line, sine is odd. So sine of negative a is the negative sine of positive a. So negative sign travels through that one. Negative sine of the tan of x to the power 3 minus cosine of x over x. And notice that this is just the negative of f of x. Thus, f of x is odd. Okay. Then last question, aside from the bonus. Last question, find the sine of 2 arc cos of 2/3, or simplify it rather. First step is I'm going to call the arc cos of 2/3 theta. So let theta equal arc cos of 2 over 3. If we take the cosine of both sides, this means the cos of theta is equal to 2/3. This invites the creation of a right angle triangle. I'll put the angle theta down in that corner, and then cos is adjacent over hypotenuse. So the adjacent is a 2, hypotenuse is a 3, and we have a missing side, which I'll call L. Okay, next. If you've done enough of these, you realize you always need to find that missing side. We're going to find that missing side like we always do using Pythagorean theorem. L squared plus 2 squared is equal to 3 squared. So L squared plus 4 is equal to 9. So L squared is equal to 5. It means L is equal to the square root of 5. Okay, why does that help us? Well, because our question, sine of 2 theta, we can rewrite as 2 sine theta cos theta using a trig identity. And then the sine of theta we can obtain from that triangle. The cosine of theta we already have, it's equal to 2/3. Okay, let's get the sine of theta. sine of theta is opposite over hypotenuse. The opposite we just found is root 5. That hypotenuse is 3. So I'm going to plug that in, root 5 over 3, and then simplify. 2 times root 5 times 2, so that's 4 root 5, and 3 times 3 is 9. So that is the answer, 4 root 5 over 9. Two-thirds, 5 over 3. I'm just making sure everything adds up. Okay, then the last question is a bonus. It's asking us to find f of 0 given that f inverse of x is equal to 3x plus 5. And there's two methods to solve this. One is a little bit more abstract, and one is more direct. So method 1. Find the inverse of f inverse. F inverse of f inverse of x, which is going to be f of x. The opposite of the opposite function is the original function. So under the strategy, I'm going to let y equal 3x plus 5, then swap. X is equal to 3y plus 5. Now solve for y. X minus 5 is equal to 3y. That means y is equal to x minus 5 over 3. And then that means, thus, since we start with f inverse and inverter, that means f of x is equal to x minus 5 over 3. So f of 0 is going to be 0 minus 5 over 3, which is negative 5 over 3. Method 2. F of 0 equals a means f inverse of a equals 0. Thus, set f inverse of x equal to 0 and solve for x. All right, that's kind of neat. 3x plus 5 is equal to 0. 3x is equal to negative 5. That means x is equal to minus 5 over 3. So two very different problem-solving strategies. Obviously, method 2 is faster, but it requires us to really know forwards and backwards what inverse functions mean. This is literally the definition of the inverse function from the first slide of inverse functions. Anyway, hope that helps.